Peanut Allergy Statistics by VECCHIARELLI.
Hi, I'm VECCHIARELLI, and this is Clyde, my trusty steed. We decided to conduct a survey of students of Scotia Glenville High School to determine if the national percentage of Americans with peanut allergies coincided with the Scotia population. A random sample of 12,032 people was taken of all Americans, which found only 1.3% of our nation has peanut allergies. Another random sample, taken by yours truly and Mr. Clyde, was a sample of 100 Scotia Glenville students, which found that a shocking 7% of its population had a peanut allergy. My null hypothesis is that 1.3% of Americans have a peanut allergy, or P equals 1.3%. My alternative hypothesis is more than 1.3% of Americans have a peanut allergy, or P is greater than 1.3%. Now, let's take a look at some graphs. According to the national statistic on peanut allergies in America, only 1.3% of Americans suffer from a peanut allergy. This graph clearly illustrates that 1.3%, or 164, of 12,032 that were randomly surveyed suffer a peanut allergy. Here, looking at the darker bar, it shows that 99.7% of the population that doesn't suffer a peanut allergy. Moving onward, take a look at the Scotia sample population. As you can see indicated by the gray part of the graph, the students with peanut allergies would be about 7%, or 7 out of 100 students. The dark gray part of the graph would illustrate the 93% of the population that doesn't have peanut allergies. Before I conducted my experiment, I had to make sure I checked all my assumptions and conditions. Beginning with the independence assumption, I decided that I will assume, you know what they say about assuming, that if one person has a peanut allergy, that it doesn't make another person have a peanut allergy. It's not the bubonic plague. It's not contagious. Then I decided to check the randomization condition, and I used my calculator to randomly select homerooms to conduct my survey method with. Then I checked the 10% condition, and I decided that 100% of Scotia Glenville students is less than the entire American population. Finally, I decided to check my success-failure condition, where I multiply the sample size times the probability that it is likely to occur, and the sample size times the probability that it is unlikely to occur, for both proportions. With the first proportion, out of Scotia Glenville, I decided to use 100 times 0.065, which is greater than 10. Then I used the sample size times the probability that is unlikely, which is 100 times 0.9349, which is also greater than 10. For my following proportion, I used a sample size of 12,032 times 0.013. That was from the national statistic, and that is also greater than 10. Isn't it, Clyde? Also, I did the probability that is unlikely times the sample size, so 12,032 times 0.987, which in fact turned out to be greater than 10. So, this condition was clearly satisfied since NP and NQ for both proportions is larger than 10. My conclusion is that now, since all conditions have been satisfied, I will proceed using a normal model, illustrated right here by yours truly and Mr. Clyde, to determine the veracity, which is a big word for truth, of the null hypothesis. I will perform a two-proportion Z interval and use a 0.05 alpha level. Beginning with the standard error, formula being the estimated probability of sample 1 minus the estimated probability of sample 2, which turns out to look like the estimated probability times the estimated probability of the unlikeliness divided by n plus the of sample 1 plus the estimated probability and the estimated probability of unlikeliness divided by the sample size, all of number 2. This will all find the square root of, which in fact turns out to be 0.007859. Right, Clyde? Then I plug that into my confidence interval formula, which is the estimated probability of sample 1 minus the estimated probability of sample 2 plus or minus the actual z value, times the standard error. This mathematically sounds like this, which is boring. 0.0651 minus 0.011 plus minus 0.7088, which I derived from my z-chart tables, times the standard error of 0.007859. This I decided based on my knowledge of statistics, which is minimal at best, and my mathematical calculations, which were perhaps considered shoddy. I'm 95% confident, so not 100%, but about 95%, that the true percentage of people allergic to peanuts will be between 0.04852951 and 0.0567046. Well, thanks for sitting with another fireside chat about peanut allergies and statistics with Nicholas and Clyde. Have a good night.